Have you ever wondered how humans managed to step out of our world and into the vast, unexplored universe? This curiosity has been the driving force behind our journey to the stars, pushing us to explore beyond the boundaries of our own planet. The story of space exploration is a testament to human ingenuity, a tale of triumphs and trials, of dreams nurtured and realized. So fasten your seatbelts and prepare for takeoff. Today we will journey through the fascinating chronicles of space exploration. The journey to the stars began centuries ago, with the invention of gunpowder in the 13th century by the Chinese. This potent mixture of sulfur, charcoal and potassium nitrate, originally used for medicinal and mystical purposes, soon found its way into warfare, launching the earliest form of rockets. Fast forward to the 20th century, the era of Robert H. Goddard, an American physicist and engineer, often referred to as the father of modern rocketry. Goddard's pioneering work culminated in the launch of the world's first liquid-fueled rocket in 1926. This remarkable feat, achieved in Auburn, Massachusetts, propelled us into a new age of exploration. Goddard's innovative spirit and groundbreaking inventions, such as the liquid-fueled rocket, revolutionized our understanding of propulsion and paved the way for future space exploration. These initial steps into rocketry laid the groundwork for the space race that was to come. The era of World War II saw a significant advancement in rocket technology. This was a period characterized by rapid technological evolution, driven by the urgency of war. The heart of this revolution was in Germany, where a young engineer named Wernher von Braun found himself at the helm of a project that would change the world: the development of the V2 rocket. The V2, standing for Vergeltungswaffe 2, or Retribution Weapon 2, was the world's first long-range guided ballistic missile. The rocket was a marvel of engineering, boasting speeds that could exceed 5,000 kilometers per hour and reaching heights of up to 189 kilometers. Following the war, the victorious Allies seized these rockets, and the technology that powered them became a cornerstone for both the United States and Soviet Union's budding rocket programs. This technological leap fueled the competition between the two superpowers, ushering in the space race. The 1950s and 60s were a time of intense competition in space exploration. This period, known as the space race, was a high-stakes contest between two superpowers, the United States and the Soviet Union, each vying to demonstrate technological superiority over the other. It was the Soviet Union that first broke the Earth's gravitational pull. On a crisp October day in 1957, the world watched in awe as Sputnik 1, the first artificial satellite, was launched into orbit. This small, beeping sphere, no larger than a beach ball, marked the beginning of a new era in human history. Yet the Soviets didn't stop there. In 1961, they once again stunned the world when Yuri Gagarin, a young Air Force pilot, became the first human to journey into space. Aboard the spacecraft Vostok 1, Gagarin completed an orbit around the Earth, forever securing his place in the annals of space exploration. However, the United States was not far behind. The National Aeronautics and Space Administration, or NASA, had been working diligently on their own space program. While they may have been second to orbit, they were determined to be first to the moon. In 1969, that dream became a reality. The Apollo 11 mission, led by astronauts Neil Armstrong, Buzz Aldrin, and Michael Collins, achieved what many thought was impossible. As millions watched on live television, Neil Armstrong descended the lunar module's ladder and took that famous first step onto the lunar surface. His words, "That's one small step for man, one giant leap for mankind," echoed around the world, marking the culmination of the space race. The space race ended with a giant leap for mankind, but the journey of exploration was far from over. The victories and discoveries of this period laid the groundwork for the advances that would follow, opening the door to a future where space is not just a destination, but a new frontier for human endeavor and imagination. The focus of space exploration then shifted towards creating a sustainable presence in space. As the 70s dawned, our eyes turned to the stars, not just for fleeting visits, but for prolonged stays. The first step towards this was taken by the Soviet Union with the launch of Salyut 1 in 1971. This was the first space station, a structure designed to remain in space without the need for constant propulsion, a home away from home for those daring astronauts. But a space station is only as good as its supply line. For this, a new kind of spacecraft was required, one that could journey to space, return, and then do it all over again. Enter the Space Shuttle. NASA launched the first of these, the Space Shuttle Columbia, in 1981, marking a new era of reusable spacecraft. These technological marvels were not just vehicles, but also movable science labs, capable of conducting experiments that would be impossible on Earth. The culmination of all these efforts was the International Space Station, or ISS, which was launched in 1998. This was a monumental achievement, not just technologically but also politically. The ISS was a collaboration between multiple countries, including the USA, Russia, Canada, Europe, and Japan. It represented a coming together of nations, united by a common goal and a shared dream. The ISS is not just a space station. It's a symbol of what we can achieve when we put aside our differences and work together. These advancements in space stations and shuttles were not just about pushing the boundaries of what was technologically possible. They were about setting the stage for the future. A future where humans might not just visit space, but live there. They paved the way for further exploration and the possibility of humans living beyond Earth. With the capability to sustain human life in space, the exploration of other planets became the next frontier. The 70s marked a new era of space exploration that extended beyond the realm of our moon and sought to uncover the secrets of other planets. In 1971, a significant milestone was achieved when Mariner 9, an unmanned NASA spacecraft, became the first to orbit another planet, Mars. This mission provided a detailed map of Mars and helped scientists understand its geology and atmospheric phenomena. Just 5 years later, in 1976, the Viking 1 and Viking 2 missions pushed this exploration further. These spacecrafts didn't just orbit Mars, they landed on its surface. Conducting numerous experiments, they searched for signs of life and gave us the first close-up views of the Martian surface. But our curiosity didn't stop at Mars. We wanted to venture beyond our solar system, to explore the outer planets and the vast expanse of space that lies beyond. To satisfy this thirst, the Voyager missions were launched. Voyager 1 and Voyager 2, launched in 1977, embarked on an ambitious journey to the outer planets, providing us with unprecedented images and data about Jupiter, Saturn, Uranus, and Neptune. Then, in 2012, Voyager 1 achieved something extraordinary. It became the first human-made object to enter interstellar space, pushing the boundaries of human exploration further than ever before. As it continues its journey, it sends back information about the regions of space where our sun's influence ends and the vast interstellar medium begins. These missions have expanded our understanding of the universe, but the thirst for exploration remains unquenched. As we stand at the brink of a new era in space exploration, we look to the stars with the same curiosity and wonder that have driven us since the dawn of humanity. The universe is vast, and there is still so much to learn. As we continue to push the boundaries of our knowledge and capabilities, who knows what discoveries await us in the cosmos? The 21st century has seen the rise of private companies in space exploration. Companies such as SpaceX, Blue Origin, and Virgin Galactic have been transforming the landscape of space travel, bringing a fresh wave of innovation and ambition to this field. Among them, SpaceX, led by visionary entrepreneur Elon Musk, has achieved remarkable milestones. They've revolutionized the concept of reusable rockets and have successfully completed crewed missions to the International Space Station. But they're not stopping there. SpaceX and other agencies worldwide have their sights set on the Red Planet. The upcoming decade is brimming with planned Mars missions by NASA, the European Space Agency, and others, holding the promise of revealing more about our neighboring planet than ever before. And then there's the Artemis program. This ambitious project, spearheaded by NASA, aims to return humans to the moon and establish a sustainable lunar presence. The goal? To use the moon as a stepping stone for the ultimate frontier, Mars. Yes, you heard it right. Crewed missions to Mars are no longer the stuff of science fiction, but a prospective reality within the coming decades. As we stand on the cusp of a new era in space exploration, the possibilities are as limitless as the universe itself. The journey of space exploration is a testament to human curiosity and determination. From the early creation of gunpowder in the 13th century to the ambitious plans for lunar presence and Mars missions in the coming decades, we've come a long way. This journey has been marked by remarkable milestones, such as the first human landing on the moon and our ventures into interstellar space. If you found this journey through space history fascinating, like this video, subscribe for more and share it with fellow space enthusiasts. Don't forget to hit the bell icon for notifications on future videos. Until then, keep looking up. Space exploration is not just about rockets and astronauts, it's about the fundamental science that makes it all possible. To truly appreciate the marvels of space exploration, we must understand the science that makes it possible. Firstly, physics plays a key role in understanding and navigating the cosmos. Newton's laws of motion and universal gravitation, Einstein's theory of relativity, and the principles of aerodynamics and thermodynamics all come into play when designing and launching a spacecraft. Then there's astronomy, the study of celestial bodies and phenomena beyond Earth's atmosphere. Without advances in astronomy, we wouldn't even know where to aim our rockets. Astronomers identify planets, stars, and galaxies and learn about their composition, movement, and the physical processes that occur within them. But the science of space exploration isn't just about getting to space, it's about staying there too. The challenges of life support systems in space are immense. Astronauts need air to breathe, food to eat, and a way to dispose of waste. They also have to withstand the physical effects of living in zero gravity for extended periods. Innovations in biology, medicine, and technology have made prolonged space travel possible. The science of space exploration is as fascinating as the journey itself, and it continues to evolve with every new discovery. It's a testament to our never-ending quest for knowledge and understanding. As we continue to reach for the stars, who knows what scientific breakthroughs await us in the future? In the next video, we will delve deeper into the science of space exploration, exploring the intricacies of each field and their contributions to our journey to the stars. Stay tuned, space enthusiasts. Until then, keep exploring, keep learning, and always reach for the stars. Looking into the future, the realm of space exploration is boundless. We stand on the cusp of a new era, where the impossible becomes possible, where our dreams of exploring the cosmos turn into reality. One of the most captivating prospects is the human colonization of other planets. Scientists and space agencies around the world are already studying the feasibility of establishing human settlements on Mars. Such an endeavor would not only test the limits of our technology and adaptability, but also redefine our understanding of home. Next, the search for extraterrestrial life continues to be a driving force in space exploration. If we were to find even the simplest form of life elsewhere in the cosmos, it would fundamentally alter our understanding of life's uniqueness and universality. The implications would be profound, potentially reshaping our perceptions of our place in the universe. Lastly, the role of artificial intelligence and robotics in future space missions cannot be overstated. Unmanned missions, powered by sophisticated AI and robotics, will likely become the norm, venturing into the farthest corners of the universe, well beyond the reach of human astronauts. They will be our eyes and ears, helping us uncover the mysteries of the cosmos without risking human lives. As we continue to push the boundaries of our knowledge and capabilities, the future of space exploration promises to be a thrilling journey. A journey that will take us farther than we've ever been, revealing the secrets of the universe and perhaps even our own existence. As we stand on the precipice of this new era, we can only wonder what extraordinary discoveries await us. Join us as we continue to explore, learn, and always reach for the stars.